What's up, math scholars? This is an exciting day. It's sunny out. There's a track meet, but the most exciting thing, the last lesson in the chapter. Woo! Who's excited? All right. Much better than yesterday, guys. All right. So all week you've been hearing me say, "Do we have a complete set of partners, class?" And you've always shouted yes. Well, today you'll start shouting no. Because if you don't have a complete set of partners, you'll be using something called the law of cosines. This is not the only version of the formula. I'll show you the other two versions, but it's probably the only one you need to write down. Basically, a couple things to take note of. If small c, side small c, lives here, then large C has to live over here with cosine. And then small a and small b would live both here and here. So just to show you other versions that would exist of the same formula, I could put small a here. That would force these two to be a b and a c. Does that make sense? And then it would force this to be cosine a large a. Right, so that's just a second version of the same exact formula. The third version of the same exact formula would put a small b here. That would make it a large b over here. And then a small a and a small c here. So just depending on how your triangle is labeled, is what version of the formula you'd use. I only have two versions of the formula on my formula board right now, so we never saw a triangle that would need the third version. So in your notes, only write down one version, that'd be fine. It is used when you don't know a complete set of partners.
What do you use more?
There's three versions. You can actually always just use version 1 if you relabel your triangle accordingly. So let's say I have this triangle and it's not labeled right now. And I have this side 12, this side 13, and this side 15. And I want to get this angle. If I label it so that this angle is C, I can always just use that version. You know what I mean? It just depends on how you label your triangle. Are you ready to move? It's totally up to you what you write down from this slide, but this is recapping basically all methods of solving triangles. If it's a right triangle, you use sine, cosine, and tangent, the SOHCAHTOA ways, or you can use Pythagorean theorem. And then if you have non-right triangles, you either have a complete set of partners and you use law of sines, or you don't have a complete set of partners and you use law of cosines. Okay. So those are all the options there are available to you. It's not like I'm going to teach you another one next week. Like, this is it. This is how you would, all the methods of solving triangles. Okay. All right, so we're going to just practice looking at 5 or 6 triangles and just saying what we would use to solve for x. If you know, you can raise a hand and we'll give a ticket out. Okay. So Nick Leaders has an idea. What are you going with? All right, Nick said we're going to use cosine because we have the adjacent side and the hypotenuse side. So I agree, that would be a great bet. Okay, and it is a right triangle. That's why he went with the SOHCAHTOA method. Number 2, what would we use? Raise your hand if you have an idea. Carly? Awesome, we do have that complete set of partners. So we can go with the law of sines. We could partner the 102 up with the 55. We could partner the x up with the 32. Make sense? Good job. What would we use? Lexi? Yeah, the new one we haven't quite learned yet. So I'll just show you how I personally would label this. I would call this my big C and this my small c. And then your a's and b's don't really matter. And then you could stick everything in the formula. Okay? So law of cosines. What would you use? Kylie? No. Try again.
Wait, one minute.
You don't have an opposite and an adjacent.
Oh, wait.
Nope. No. Andrew?
Sine.
Sine. Yes. So you were right when you picked tangent. It is a SOHCAHTOA method because of the right triangle. But the 17 is an opposite and the h is a hypotenuse. You okay with that? Opposite, hypotenuse. And use sine. So you would say sine of 22 equals 17 over x, like that.
Yeah.
22 would be the theta. Yep. What what would I use? Spencer? It's like he already has hand up before I put the slide up. Oh, sure. Alright, so law of cosines on this one, and then Spencer made a scholarly observation that once you use law of cosines to solve this side, you will know a complete set of partners at that point, and you could transition to the law of sines. So let's actually head back to the lesson just to save time today, and try one of these law of cosine problems. So you should be noticing right off the bat, you just don't have that complete set of partners that we've been loving all week, you know? I love having a complete set of partners. We don't have it right now. Huh? We have side, angle, side. So we don't have a complete set of partners. We're going to use law of cosines. So if you want to label this large c and this small c, then we'll be able to use this first version of the formula that we had written down. It doesn't matter if you make the 27 your A or your B. It's just the c's that are really going to matter. All right, so here goes my formula. C squared equals A squared plus B squared minus 2AB. So once you use the 27 and the 15 once, you end up using the 27 and 15 again. It always works like that. And then cosine C. That's where your angle goes. Do you think we could type in all this at one time? I say that so much, I'm always like, don't type it in all at once. You actually can type in all this at once. So that's exciting. That's be music to your ears. You can type it all in at one time. It's going to be a pretty big number because we will still have to square root that number. That would be almost a little too much. It would require a double set of parentheses because your calculator puts a set of parentheses here. So 744 point anything that would require parentheses within parentheses, I tell people don't do it. All right, and we square root both sides. Second square root, second answer. What'd you get? Just try it one more time. I got 744. 27.28. But yeah, we're going to stop here, but that would complete a set of partners that if we would need to solve the rest of the triangle, we could use that complete set to transition to law of sines. Right? So fun typing it all at one time and just square rooting it at the end. Alright, so since solving for sides is easy, let's do one where we have to solve for an angle. That's a little bit harder. So here's your picture. Do we have a complete set of partners, class? No, we don't have any angles right now, do we? So since we have like this formula 1 with large C, let's go ahead and just solve for large C first. Okay? So we'll do C squared equals A squared plus B squared minus 2 times A times B times cosine C. Look at that. Our variable is embedded in that right-hand side with all that stuff. Do you think we could type in all this stuff at one time? Absolutely not. The most you'd want to type in at one time is this number, and then you can type in these two at once, and then you can type in these three at once. But you don't want to type in like all of it at once. Okay? But I kind of underlined what you are allowed to type in at one time. So 20 squared is easy, that's 400. 12 squared and 27 squared is 873. 2 times 12 times 27 is 648. And then you have that times cosine C. Well, how are we doing on our calculations? At this point, this is the step everybody will make their mistakes on if they make a mistake. What I will see students do is 873 minus 648. That's wrong. Can't do that. The 648 is attached to the cosine C, and the only way it can kind of unattach itself will be to divide to the other side. So you want to take this 873 and kind of move it to the other side first. But if I see mistakes, it's definitely trying to do that subtraction when you're not allowed to. So 873 minus 400 is 473. Oops. Oh, I messed it up. Oh, negative. Thank you. You just saved the day. And then we have a negative 648 and a cosine C. Need a lot of workspace. These are the ones that take forever. Just a lot of workspace. Getting that the negative 648 over, you have to divide it over. That's going to give you that really small decimal between 0 and 1 that we saw yesterday. So negative 473 divided by negative 648 is 0.7299. And then what do you think we'll do to finish? Cosine inverse, yeah. Anytime you're solving for a missing angle, you end up doing an inverse at some point. So second cosine, second answer, 43 degrees. Now that I have that 43 degrees, like Spencer said, I've got a complete set of partners. Isn't that awesome? Give myself some workspace here. Our complete set of partners is that 43 goes to 20. So I can transition the law of sines and do sine of 43 goes with 20, and sine of A goes with 12. Now we're just doing methods we've done in the past couple days. We can do our cross multiplying. 12 times sine 43 divided by 20. And then do a sine inverse at the very end. Second sine, second answer. Now, since we did a sine inverse, we do need to explore the possibility of the supplement of A also working for A. What's the supplement of A? 180 minus 24? Is 156 too big, or would 156 work in place of A? 156 plus 43 is 199. So too big, which is great. Awesome sauce. All right, so then let's get B. We know A is 24. We know C is 43. We can subtract those numbers from 180. 113? Once I had this 24 and I already had the 43, I know all triangles have 180 degrees. Look. Heron's formula is a formula that a Greek mathematician named Heron came up with, but it's basically a way to take a triangle where all you know are the measurements of 3 sides and still come up with the size of it, the area of it. So you have to do something called a semi-perimeter. It's a half perimeter first. So that's what you'll do first. You'll find S, which is a semi-perimeter, by basically finding the perimeter, cutting it in half. Then you'll use that S value in this huge, huge, huge square root problem. That is S, S minus A, S minus B, and S minus C. It's not as hard as it looks. I know it looks super long and complicated, but it's pretty easy. So once you write the formula down, we'll try one of them. All right, we're ready to try one of these. So all we know is what the lengths are of our 3 sides. We can definitely utilize Heron's formula to get our area. Let's start by finding our half perimeter. So you're going to take half of the perimeter. The perimeter would be 5 plus 8 plus 11. So that's 24. And what's half of 24? So S is going to act as our semi-perimeter. I shouldn't have put that in a box. That's not really my answer. It's just going to help me use the formula. All right, so here's how Heron's formula works. You take the square root of S times S minus A, S minus B, and S minus C. Now, do you think we should type this in all at one time?
Sure.
Probably not. There'd be like too many parentheses within a parentheses within parentheses. Okay, so I would just actually use my brain to help me out with the baby steps. What's 12 minus 8? What's 12 minus 1? 1 minus 11 is 1. What's 12 minus 5? And now you can maybe type this all at one time.
7, 20, 28 times 12.
So the square root of 28 times 12, says Andrew. 18.33. And that's the area, so we go with unit squared. I'm not mad at all, right? So I'd say once you're done writing that down, you can be done today. 'Cause we are about out of time. Thanks for watching the video. The homework is out of the book, so I'll move to that slide in a second.
Yeah.
Here's the homework. Make sure to subscribe and hit the bell for your notifications. Goodbye.